So we are trying to predict whether a compound will dissolve in water or not. And it's a big deal because what we're going to get at in the end is how much will dissolve in the water. And that's probably even more important, right? But because just think of it. I mean, you have commercial products. How much is it going to dissolve in your blood, right? Or let's say you're trying to make a commercial product. How much of this stuff is going to actually dissolve in the water that you're trying to make, right? Or whatever the compound is. Just because not everything dissolves. So what we're talking about is, well, these problems are trying to determine whether the complete thing dissolves or not, really. But life is really more complicated. Like here's a Twinkie. And we're not supposed to use the word dissolve either. Sorry, Audrey. We're supposed to use the word, starts with an S. Soluble, right? So is a compound soluble in water or not? Well, here's some little fishies in a lake, and that killer virus, it's in our water. Relax. There's also enough prescription drugs, and we'll be okay. That is getting to be a big problem in the United States. We are a very medicated society. Where's all this stuff go? You take Advil, you take whatever compound, your body metabolizes less than 10% of it. The rest you just whiz it all out, right? Where does it go? Lakes, streams. Well, where does all this stuff go? It's supposed to go to our sewage treatment plant. So we had a research project, and the influent is what's going into the chemical treatment plant, right, or sewage treatment plants, and the effluent is what's coming out. So we analyzed what's going in and what's coming out. So I showed you those fancy instruments like the GCMS upstairs. And here's a result. So every time you see a peak, that's a compound, okay? And there's a lot of compounds in the influent. Well, in the effluent, what's coming out of the sewage treatment plant, still a lot of compounds, right? Its purpose, it can't get these compounds out of the water. So, I mean, it cleans up some stuff, and we identified only 2 of these compounds. We identified 2 of them. One was Advil, ibuprofen. Another one was naproxen, which a lot of people take for arthritis. So I'm not sure where those peaks are in there, but we found those. But it's something that we're going to have to deal with sooner or later as the society. But what happens when an ionic solid dissolves in water? Let's take a look at this. So here's our ionic solid, right? And all these little guys floating around are what? Are what, Bowdy? Water molecules, right? So can you see this thing? They're pulling off a chunk of this solid. Now that solid is sodium chloride. Okay, so there's sodium ions and chloride anions in here. So that's why there's 2 different spheres. Can you guess which ion this is? Is that the sodium ion or is it the chloride anion? The only hint that you have is look at the water. The water's oriented around it. This is what happens when things dissolve. This is what they believe is going on at this atomic level. These water molecules orient themselves differently around the different ions. All right? We keep going. So this is how they orient themselves around the gray sphere. You keep going. See, look at this. Now, are these the H atoms? Like, this is water. Are these the H atoms or the O atoms, these 2? Because water's H2O, so these guys have to be the H's. And the O's sticking out here. And we haven't really got into this yet, but different atoms, the electrons spend more time around different atoms than others. They call it electronegativity. And the point is oxygen loves electrons. It hangs out there. So water really isn't neutral. I mean, this has a kind of a negative charge to it, and these guys kind of have positive charges. So if the positive H's are all surrounding this guy, that means this must be Na plus or Cl minus. Cl minus, because plus and minus stick together. Exactly. So this is the chloride anion. And then the H pluses kind of stick around there. Now they're not tearing off the water, they're just kind of hanging on to it. So over here you've got the Na plus, and what's sticking on it? Well, the oxygens. And it's not a chemical bond, it's just an interaction, just interactions between molecules. And we'll get into that too, it's intermolecular forces. But so you can pull this stuff apart, it's no big deal. It's just that this is how they're interacting. And that's dissolving. Okay. Not all compounds are going to do that. Compounds that do this, that dissolve, are soluble. Ones that don't are not soluble but insoluble. Exactly. Okay. Let's see. So writing ionic compound formulas and breaking them up. We have potassium phosphate. Kendall, what are the charges on this compound potassium phosphate? It's K what? And K is plus 1.
And then is the negative 3.
Oh man, good. She remembers this stuff. So a 3 goes down there, right? And the 1 down there. So that means this potassium phosphate compound would break up, Bowdy, into what ions? Assuming it does break up. We'll find out that later. It would break up into a potassium with a plus and phosphate. Except, is it 1 to 1? Yeah, the 3 goes in front of the... Yeah, the potassium, right? Because there's 3 Ks. If you're going to find the, for example, go back and find the molar mass of this thing. It'd be 3 Ks, 1 P, and 4 oxygens. Yeah, so you have to have a 3 in front of the K plus. So the subscripts just become the coefficients, right? Just remember, that's phosphate. So you don't move that 4 out because that stays there, right? It's phosphate. Okay, so we're going to be playing with that. Make sure we're on the same page here, Stephen. If an ionic compound dissolves in water, breaking up into its ions, then the compound is said to be... Which one? Soluble. Exactly. That's the terminology we have to get used to. So we have these subscripts, A, Q, and S. If it's soluble, for example, sodium sulfate is going to be soluble. And I'll give you the rules, no big deal. So I'm telling you that sodium sulfate is soluble. Do we write an AQ or an S as a subscript? AQ. S probably just stands for solid. You'd think S would stand for soluble, but it doesn't, right? S stands for solid. So you're supposed to write an AQ down there as a subscript. Now, according to the rules that we haven't talked about yet, calcium hydroxide is insoluble. So the subscript actually we're supposed to put on calcium hydroxide would be S. Right. Okay, so here they are, the solubility rules. So let's practice a few here, right? Now, this table is a little bit bigger than what I'm going to give you. In fact, if you go to the next page, you see the table I'm going to give you, all right? So I think it's a great idea for you just to tear this page out and have it staring at you when you're doing all your homework. Because this is what you get on all the quizzes and you get on all the exams, right? There's this table of rules, and then there's some common reactions, which we haven't got to yet. So this table of polyatomic ions isn't there, but it's there just so we can remember stuff here. We want to circle the soluble compounds. Okay, I'll show you how to do this first one. It's calcium chloride. So we have to look for the calcium or look for the chloride. Now the calcium's nowhere really to be found, and where I'm looking are these. So the chloride is there though, because here it is. And it's listed under soluble. So that means, hey, go put an AQ or an S on it. Put a AQ because soluble is AQ. All right? Okay, but you got to be careful because there's exceptions. You come over here and you look. So you right away you want to put AQ on all these. all of this, you want to put AQ on it. Just be careful because there's some exceptions. So you should check them. Is calcium listed? Nope. So that means we stay at AQ. So we'll circle that one. Okay? Does that make sense? So check if it's one of these anions, it's always going to be AQ, but just check the exceptions and make sure it's not there. Because if it's an exception, then it has to be a solid. So out of the rest of these, go ahead and circle the ones that should be soluble. And if they're soluble, circle it and write a little AQ on it. I guess if it's solid, go ahead and write an S on it. Do that with the rest of them. See if we're reading this table right. Is anybody not sure what I'm trying to get you to do here? Manuel, see this? Okay. So Emily, do you circle calcium hydroxide? She circled it. That means that we could also write a subscript S. Does everybody agree with that? All right. So calcium's nowhere to be found, but hydroxide is. Here's hydroxide. It's in the insoluble thing. So odds are she's right. Except we better check the exceptions. Right? So come across compounds of ammonium. Well, it's not ammonium hydroxide. And the alkali metals. Oh, you got to remember what the alkali metals were. What were they? They were group number. If it was 2, she's wrong. But alkali metals is group number 1. Group number 2 was the alkaline earths, right? So alkaline or alkali, group 1. Alkaline earths, group 2. So alkali metals, that's group 1. So she was right. Okay. She was right. How about calcium sulfate? Connor, you circle it or not? Circle means soluble. Oh, sorry, I wasn't supposed to circle that, was I? I just wrote an S5. Circle it. Or aqueous. Do you agree? I don't even know. I got to find it. Where did you find sulfate? Sulfate's in the bottom? Oh, here it is. All right, there it is. It's aqueous, and there's not an exception. Good deal. How about lithium bromide? Kenneth, did you circle it? Is it aqueous or insoluble?
It's aqueous.
Aqueous.
On CaOH.
CaOH is a solid.
But on the exceptions.
Oh, there's another row of exceptions. Did you notice that? Thank you, Connor. Did you see that? There's 2 rows for the exceptions for hydroxide. Oh, you gotta talk louder. All right. So you guys can read this table better than I can. There's 2 rows. So there's 2 rows for the sulfide too. Did you notice that? There's 2 rows for it. Clean this up. It's getting ugly. Thank you, sir. Okay, how about ammonium chloride, everybody? Aqueous or solid? Aqueous. How about lead 2 iodide? Solid or aqueous? I hear solid. Dylan says solid. Everybody agree? Solid? Yeah, because here's iodide, but there's lead. It's the exception. Okay? So that's part of the game we're going to be playing. Here's the handout that you should be ripping out and using. Right? Kind of nice because you notice now, if you don't have the polyatomic ions, the formulas memorized. Well, now they're given, but the names aren't. So you still got to know the names of them. Okay, water soluble. Let's just do the first three, then we're going to move on. Right? Now let's do the first four. So we're not going to the boards yet. So if it's soluble, right, write the ions that are going to be there. So what I'm shooting for is like KNO3. Look at the rules, right? There's no exceptions even with nitrate. So that's definitely going to be AQ. So then you draw a little arrow and break it up into its ions. Okay? So that's the game that you're playing here.
When there's an exception on this side, does that mean it is?
So that now that means that it's going to be soluble.
Oh, okay.
Because it was, all this stuff should be insoluble.
Okay. I know what this is.
Anybody not sure what to do here? Don't forget the charges though. K plus, NO3 minus. Yeah, and make sure you write the charges on these ions, right? So you're right by writing K and NO3 if you wrote that, but you're not going to get any points because these aren't ions. You got to have the charges. Okay. So Rebecca, is lithium carbonate soluble or insoluble? Is lithium carbonate B soluble or insoluble? Insoluble? Let's check. Doesn't sound right. Because you have carbonate. Oh, carbonate. It looks like it's insoluble. Looks like she's right. But then you check the exceptions. All right? In fact, you know there's an easy way to do this that covers a lot of them. Whenever, look at the alkali metals. Whenever you see an alkali metal, lithium, sodium, potassium, whenever you see it, it's always soluble. It's always AQ, whenever you see it. So you really don't even need to check the solubility rules when you ever see an alkali metal. So there's an alkali metals, it's going to be aqueous. It's going to break up. What ions will it break up into? Tanya.
Lithium 2
Lithium,
and
Cl3. Okay. Now we need the charges and we need the little coefficients out front. The charge. Now you can figure it out from the formula, right? If you put parentheses around this has to be a 1. Carbonate has to be a -2. So that's that part. But it doesn't fix the coefficients. What do you have in front of the Li? 2, because you have 2 of them. Right? If you're going to find the molar mass of this, you'd have 2 lithiums there. And then only 1 on the carbonate. How about iron 2 acetate, Sarah? Is that soluble or insoluble? Iron 2 acetate. soluble. Good. She read it right. AQ. So she's right, Dylan. That's going to break up into what ions? Fe with a charge of plus. It would be 2, right? It would be 2. And then that acetate, that big acetate thing, with a charge of -1. Perfect. How about lead 2 chloride, Alyssa? Soluble or insoluble? Yes. Oh, I forgot to. Man, I didn't take my fish oil today, so that's showing. Should be brownie points for that, right? And then she nailed the insoluble. All right? So no ions to write. You just leave it alone. It just lays there in the water. Doesn't do anything. Okay? Okay. So I kind of went through that stuff a little bit quickly because this is the meat. This is what everything comes down to, is writing molecular equations, ionic and net ionic equations. So let me go run through this first one for you. Molecular just means no ions. Just don't write any ions, right? Write all the compounds and make sure it's balanced. Ionic, right? Break up everything into ions. Net ionic, cancel any ions that you can. So if you see a sodium ion on both sides, you just cancel it. Okay, that's the game we're playing. And a lot of it's going to look like this. We're adding aqueous solutions of calcium chloride and lead 2 nitrate are mixed. Right? Balanced molecular ionic and non-ionic equations. So we're mixing 2 things, and then we're going to get a product. So this is how I start out. I identify what the 2 reactants are, and the 2 reactants are calcium chloride and lead 2 nitrate. So calcium chloride, and the subscripts are huge. Calcium is in group 2, so I need a plus what on it? Plus 2. Chloride is 1 over from the noble, so that's a -1. So it's really CaCl2. Right? That's very important. Then I have lead 2 nitrate. Lead 2, so that means it's a plus 2. And the nitrate, I like parentheses around all polyatomics. Nitrate's a -1. Remember, the charges become the subscripts. Okay. So now what we do is we look and see if this stuff is, we pretty much just kind of switch them around. Okay. We look at, combine the calcium with the nitrate. Combine the lead with the chloride. See that? You just kind of switch the cations and anions around. So we'll combine the calcium with the nitrate. Okay. And I just like to write the ions because then I can move the subscripts around as the last step. So I'm combining the calcium with the nitrate. So the 2 has to go down there. Right. And then I'm going to combine the lead with the chloride. So we'll combine the lead with the chloride. So do you see the trick to doing this so you don't mess up? Just combine the ion. Write all the charges, then just combine the ions, because then hopefully you'll remember to move the charges to be the subscripts. Okay, now what we got to do is put subscripts on this thing of AQ or S, on everything. Okay, so calcium chloride, Sydney, calcium chloride, would that be solid or AQ? Calcium chloride. let's see, here's chloride right here. It says it's soluble, and calcium's not in the exceptions, so it stays soluble. So that would mean it would have to be AQ or S? AQ. Perfect. So that has to be AQ. Okay. And lead 2 nitrate, Megan, would that be AQ? AQ. And calcium nitrate, Paul, would that be AQ or S? AQ. Perfect. And lead 2 chloride, Manuel, AQ or S? S. All right, you guys are reading this good. Now this is where I always forget. I want to keep going, but you got to check and see if it's balanced. Right? Do I have one? I have 1 calcium on both sides. I have 1 lead. I've got 2 chlorides, and I have 2 nitrates. So I'm okay. But remember to check to see if you're balanced. If you're not balanced, you got to, put some stoichiometric coefficients there to balance it. I almost always forget that. Okay, so ionic, the trick there is just break everything, Giselle, up into its ions. So you break up everything that has an AQ. Break up everything that has an AQ. So you break up calcium chloride into its ions. So you would write what? Ca with a +2. Cl -1. But how many? 2 of them. All right, that one's broke up. Now we got to break up the lead 2 nitrate, Mia. You break it up into what? Pb +2. NO3 -1. But don't forget, there's how many of them? 2 of them. Okay. And that goes to calcium nitrate, Lauren. And good. Okay. And then Audrey, what do we write for this lead 2 chloride? Yeah. Do we break this one up? No, because it has an S on it. So we just leave it alone. PbCl2 solid. Okay. Now, can we cancel anything? Lorena, we're supposed to, net ionic, you cancel what you can. Are there any ions or anything that you can cancel? See it on both sides. The calcium, good. Is there anything else? Oh yeah, I didn't notice that one. And that's it, right? Okay, so then you just write down what's left over. All that's left over are 2 chlorides, a lead, and on this side, PbCl2. Okay. So this is the game we're playing today. That's the homework. They're going to give you a reaction, and you write the molecular, ionic, and net ionic. All the work is in that molecular equation. If you do that right, the rest just falls into place. Okay? And I'm sure there's going to be some of these in the homework where if you have AQ on everything, would everything cancel? Yeah. And then you're supposed to write no reaction. If everything cancels, there's no reaction. Now, just some hints so that things don't get so frustrating for you. This is the one thing that's really helped me. Man, you can fly in your homework. If you remember nitrate, ammonium, and all the alkali metals, whenever you see that stuff, it's always AQ. Always. They don't even need to check the table. if you see nitrate, ammonium, or all the alkali metals, right? I mean, you can even throw acetate in there too if you want. Okay, but that's, you hardly ever see acetate, so I don't really add it. Okay, so bring your cheat sheet up with you, and let's do this one together. Go up to the boards and write molecular, ionic, and anionic equations for sodium sulfate plus barium nitrate. Right, molecular, ionic, and anionic equations. So spread out as much as you can. Start high, because you're going to write one equation right below the other. And try to line up your arrows. Notice how I did it? I really tried to line up my arrows so it's easier to cancel stuff. Okay. So write small. Write small and line up your arrows. Sodium sulfate plus barium nitrate. Sodium sulfate and barium nitrate. So on your two reactants need to be sodium sulfate and barium nitrate. And if you're not sure what sodium sulfate sulfate was, look at the cheat sheet. It's on there. Sodium sulfate and barium nitrate. Good. Well, Dylan, barium is Ba. Yeah, barium is Ba. Yep. Oh, what did I say? Jeez, I'm so off today. What's going on with me? And you're right, it's a +2. You got that. Good, very, very good. You got it. Yeah, and so here, and if you're not sure, we have that cheat sheet, this thing, right? Sulfate, sorry, -2. All right, so then that 2 would have to go down there. Whoops, sorry. Good, 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 good. Oh, use the cheat sheet, Lauren. Look, nitrate. Nitrate only has a -1.
You picked it up when I was going to look.
Right, -1. Okay, good. So the 2 has to go down there. And then for products, just shift the cations and anions around. Good. Good. I think everybody agrees so far. Good. Now just switch the cations and anions around. Yeah, so Giselle, just put, I think it's a good practice just to always put parentheses around polyatomics. And then, so then that means that 2 has to go down there. Yep. Now, write the charges. So a plus and a minus. So that means this is a 1 and that's a 1. Right? Because Na is a +1, nitrate's a -1, so it's just 1 and 1 down. Yeah, plus 1. Yeah. So use that cheat sheet. Yep. You can keep going if you're flying. Uh-huh. Oh, this is a good one. All right, because you have to balance. This is the good one, because you have to balance it, right? So before you move on, hopefully you identified that. You have to put a 2 in front of the sodium nitrate. All right, because there's 2 sodiums and 2 nitrates on this side. So once you get it nice and balanced, write AQs and S's on things, and that, sorry, that's molecular. Man, I don't know what's going on with me today. I need more sleep or something. Barium sulfate. And just don't forget to put your S on this, otherwise you get docked. Yep, perfect. Yeah, so the ionic, now I just put, you see sodium, so it has to be AQ. Nitrate has to be AQ. And then the next step, the ionic, wherever you see an AQ, you got to break them up. Yeah, so now here you have to break him up, so it'd be 2 NAs and a sulfate, right? Because you have a 2 down here. So the 2's, the coefficients actually come out front. Na plus, because that should be a plus. Yep. And 1 sulfate. Okay, so there's my ionic equation.
Like this, since it's 2.
Yeah, since it's 2 sodium nitrates, you're going to end up with 2 Na pluses and 2 nitrates.
So it was like, there's a 2 down here.
Then you'd end up with,
multiply. 4.
yeah, you'd end up with 4. Like here, this would be a good one. If this would have been a 2, you'd end up with 4 of them.
4.
Yeah.
All right.
So make sure this makes sense so far, right? Make sure I didn't lose you. Because I've got to balance it in my molecular, I had to have a 2.
Oh, you did that.
Yeah, you had to put a big 2 in front of that because you don't have your sodiums weren't balanced. So Kendall and your no up on top, you should have 2 NaNO3, 2 sodium nitrates. I should have my little pointer. Let me get my little pointer. Oh, sorry, Kenneth. Let me show you. So this is where I screwed up a lot. So when you're doing the molecular, you have to make sure it's balanced. You have 2 sodiums, you only have 1 sodium. So you have to put a 2 right here.
Oh, in the beginning?
In the front of it. So you have to write a big 2 right here.
For the ionic one?
No, right here in the molecular, before you can even move on to ionic. So before you have to balance the molecular before you even move on. And that's a very common mistake. So now when you break this up, you're getting 2 sodiums and 2 nitrates. And don't forget your charges. You got to have your charges. And all these guys, you got to have your charges. Otherwise, you can get docked.
Okay. Oh, wow. Okay. Yeah,
Now on ions, you don't have to write AQ on. Ions, you don't have to write AQ on. But the rest of it should work. All right? So then I'm going to cancel what I can. Let's see. Sodiums were gone. Nitrates were gone. So all that's left is a sulfate and barium forms barium sulfate solid. Okay? So that's the game you're playing in your homework. And that's what's going to be on the quiz. So make full use of this cheat sheet. Right? Because it has the charges and everything on there for you. Okay? So have a good day.